rather I should say the science of semiconductors. Pure silicon is a semiconductor, which means it conducts electric current better than insulators, but not as well as metals. And this is because an atom of silicon has 4 electrons in its outermost or valence shell. And this allows it to form bonds with its 4 nearest neighbors.
Howdy-ho there.
Right.
What's up?
So it forms a tetrahedral crystal. But since all these electrons are stuck in bonds, few ever get enough energy to escape their bonds and travel through the lattice. So having a small number of mobile charges is what makes silicon a semiconductor. Now this wouldn't be all that useful without a semiconductor's secret weapon, doping. You've probably heard of doping. It's when you inject a foreign substance in order to improve performance. Yeah, it's actually just like that, except on the atomic level. There are 2 types of doping, called N-type and P-type. To make N-type semiconductor, you take pure silicon and inject a small amount of an element with 5 valence electrons, like phosphorus. This is useful because phosphorus is similar enough to silicon that it can fit into the lattice, but it brings with it an extra electron. So this means now the semiconductor has more mobile charges, and so it conducts current better. In P-type doping, an element with only 3 valence electrons is added to the lattice, like boron. Now this creates a hole, a place where there should be an electron, but there isn't. But this still increases the conductivity of the semiconductor because electrons can move into it. Now, although it's the electrons that are moving, we like to talk about the holes moving around because there's far fewer of them. Now, since the hole is the lack of an electron, it actually acts as a positive charge. And this is why P-type semiconductor is actually called P-type. The P stands for positive. It's positive charges, these holes, which are moving and conducting the current. Now, it's a common misconception that N-type semiconductors are negatively charged and P-type semiconductors are positively charged. That's not true. They are both neutral because they have the same number of electrons and protons inside them. The N and the P actually just refer to the sign of charge that can move within them. So in N-type, it's negative electrons which can move, and in P-type, it's a positive hole that moves. But they're both neutral. A transistor is made with both N-type and